All right, hi everyone. Yeah, so we're going to do something a little bit different here. We're basically going to be going through building a Shiny app. Before we do that, quick show of hands, who's building Shiny apps, knows about Shiny apps, interested in Shiny apps? Wow, okay, awesome. That is great. Okay, so the Shiny app we're going to build today is relatively simple. It's going to let a user click on a country and chart the price history of the iShares ETF associated with that country, right? So we're going to pipe it into DY Graph. We're going to pipe it into HiCharter. This is a really simple Shiny app. This is probably the simplest R code that we've seen throughout these last 2 days. There's no math here. There's no modeling. There's no optimization. We're just taking the time series and we're charting it. So a fair question is, why am I going to spend the next 15 minutes talking about this? And there's 3 main reasons. So one, even though this is very simple, it doesn't have to be simple, right? We don't have to just take this data and chart it. We could run it through a function or a model and chart the results of that model. So hopefully this will just be kind of a demonstrative app for much more complex work that quants like you guys can do and that simple guys like me cannot do. But more generally, the second motivation here is to just sort of think a little bit more about how to keep our end users or our end consumers in mind when we're writing our R code. Right, so one of the reasons I kind of like this app is that people like to click on maps. I don't know why, but you know, if you pick up the New York Times website or The Economist, they have interactive maps in there. People like to click on them, and if people like to click on maps and we can wrap our work around that somehow, that means people are going to like to interact with our work. And that's a good thing. So I'm going to try to convince everyone here that putting in that extra time to wrap things up into an interactive app is worth it if it'll get more people to engage with what we're doing. And the third sort of motivation that we're going to try to get out of this is just thinking through the workflow of creating this app. Because I know it can be seem a little bit mystifying. Well, how does a model end up in a map like this? All right, so let's toggle back to the beginning. So we're going to leave this Shiny app and we're going to go to an R notebook. And this notebook is static, but this is where we're going to do all the hard work to create this app, and then we're going to do the fun stuff in the actual Shiny file. All right, so if people aren't familiar with an R notebook, it's just it's an R Markdown format. It's available in the IDE, so when you want to open up a new file, if you have the latest version of the RStudio IDE, instead of having just the choices for an R script or an R Markdown file, there's a choice for an R notebook. So this is a rendered R notebook. It's an HTML file, but it's a special HTML file. It has this nice code button up here at the top, so if we wanted to share this HTML file with someone who did not care at all about our R code, we could hide it all. If it's someone who does care about our code, they can show all code. They can also download the raw Markdown file that was used to create this. I won't do that for the sake of whoever owns this laptop, but if you're sharing this notebook with someone who wants to replicate your work, they can download your script and run it and see if they can indeed reproduce your work. All right, so turning our attention back over to that Shiny app, obviously we need the ticker symbols for those ETFs because that app in real time is sending those tickers to get symbols, you know, pulling in the price data, and then we're passing that price data to DY graphs and HiCharter. So we need those ticker symbols, and like I said, this is the most simple thing we've seen during this presentation. There they are. It's a vector of ticker symbols, a vector of country names, a vector of year-to-date data, and then we're gonna stick them into a data frame. Why did I even bother with this code chunk? Why am I even talking about it? The reason is that even if something is really simple, and possibly obvious. I still think it's a good idea to just go ahead and give it its own code chunk, because in 6 months, when you open this up and you want to rebuild it, or one of your colleagues opens it up and wants to try to reproduce this, if they look at your first code chunk and think, this is so obvious where this guy got his data, why did he even do this? That is fantastic. Okay, so if someone's trying to reproduce your work and they think it's obvious, that's good. That's much better than the opposite extreme, which is that they can't figure out what you were doing or thinking. So a nice thing about the notebook, we get to kind of peek at our data frame here, so we can confirm we have a data frame with tickers, the name of the country, and the year-to-date data. The next thing that I think we want to do here in this notebook is make sure these tickers are what we think they are. So we're gonna pass them into QuantMod, and we're going to use the per package to iterate over all the elements of the symbols. This is not really a necessary step, right? So I'll just toggle back over real quick. So every time we click on a country here, we are passing the ticker out to QuantMod and pulling in the data in real time. The purpose of this code chunk is to make sure we haven't made any mistakes, right? Because we want to find those mistakes before we kind of push things up into the shiny world, where we would have to click on all 41 countries and make sure that indeed the ticker symbols do what we think they're going to do. So that's what this code chunk is going to do. We're going to call get symbols on our tickers column. Then we're going to use the map function. If you're not familiar with the map function from the per package, it's similar to the apply family. It's going to let us apply this get closing prices to the elements of this vector here. We could stop there. We'd have a list of time series objects, but we're going to also use the reduce function to merge them into one big XDS object, just to make it easier to look at them. And we've confirmed that those tickers do what we want them to do. So now it's on to building a map of the Earth. This used to be a little bit more complicated, but in March of this year, someone released this great new package called Our Natural Earth. It makes it really easy to build a map of the world. Has a function NE_countries, natural Earth _countries, and we're going to call for a map of type countries, and return class SF. SF stands for Simple Features Data Frame. We could have put SP here and gotten the spatial data frame. The code would be virtually identical if we did that. SF incorporates some more tidy features to spatial data, so I kind of prefer to work with simple features data frames. And we're going to store that in an object called world. World has some cool stuff for us: the name of the country, GDP estimates, the economy. So we're going to use that to just build a test map to make sure it does what we want it to do. We'll give it a blue palette, shaded by GDP estimates. We'll create a pop-up so when a user clicks, something happens, so they know that they've actually clicked. And then we're going to pass all of this into leaflet, right? And we're going to build a map of the world. This is not the map we're going to use in our Ultimate Shiny app. This, again, is really just testing to make sure that the objects we've created do what we think they're going to do. And this one does. All right. But what we really want to do is create a map that's shaded by the year-to-date returns of those ETFs and that somehow has the ticker symbols available to us. So to do that, we're going to merge together the two objects we've built so far. So we have this world object, and we have our data frame that holds our tickers and our year-to-date data, and we're going to merge those together. And that's going to create one object that I've titled world_ETF that has all the data we need, basically, right? It has the spatial data that we need. It has the ETF data that we need. And since we don't want to shade this by GDP estimates, we actually want to shade by year-to-date data. And how about red, yellow, and green instead of blue? We're gonna create a new palette. And again, I'm sure even as I'm saying this, you're thinking, all of these steps are really, really simple. Why are they broken down in such a simple way? I kind of over-exaggerate breaking things into simple steps so that when I pick this up again in 6 months and I want to build a different world map and merge different data into it, it's easy to sort of take this notebook and use it to build a new map. We also, I think it'd be good to have a pop-up that says the actual year-to-date performance, just to make things easier on our user. And we're gonna rebuild another map, this one shaded by year-to-date performance. There's one huge difference between this map and the previous one besides the color scheme, and that is this layer ID right here. Okay, we're gonna put a layer over this map that is the tickers. And that is a very, very, very important piece of this notebook, because it's how we're gonna somehow pull the tickers out of this map when someone clicks and pass them into get symbols. It's not really the type of thing that jumps out at you when you're trying to go through and find the differences between these two maps, but this is really, really crucial. And we're gonna save this as an object called leaf_world_ETF, my naming conventions. And this map should look really familiar, really, really familiar, because it is the exact map we're gonna use in our Shiny app. It's shaded by year-to-date data, it has the tickers in it, and they're available as a layer ID. All right, so the last thing we're gonna do here is we're gonna save this object, leaf_world, in a file called etfdata.rdat. And if we toggle over to the source code for the Shiny app, the first thing we're gonna do is load that .rdat file, okay? And that's what I mean by the hard work was done in that notebook. The first thing we do is load that map, and now we just have to figure out a way to extract those ticker symbols. So if anyone's kind of curious about the format I'm using to build this map, this is also an R Markdown file, but we're calling runtime Shiny on it, and we're using Flex Dashboard for some formatting. Maybe a lot of you are more familiar with the kind of app.r format for building Shiny apps. You definitely use those to build this exact map. But if you look through this code, you will notice there's no UI or server logic in here. So if you build your Shiny apps using Flex Dashboards and R Markdown, you don't have to keep track of your UI and server logic. And for me, that was pretty much the end of the discussion for which file format I'd be using. But you can do all of this in an app.r file also. All right. So in our setup, like I said, the first thing we're gonna do, we're just gonna load up that rdat file that we saved. And the only thing we had saved in there was our leaflet object of the world. We could have saved other things, but we don't need them. And the first thing we're gonna do is render that map. Okay, so that's why this map looks the exact same as this map. They're the exact same, okay? So again, everything was built in this notebook. And now we need to figure out how we're gonna get these tickers and pass them into QuantMod. So, remember we had that layer ID that was called tickers. And we're gonna use a reactive here, but it's gonna be based on an event. And that event is going to be when a user clicks on a shape in the map. Okay, I know this is a little bit in the weeds, but this is a really important line of code. So the event is a click, and then we just wanna grab the ID. And we said that layer ID was the ticker symbol. So these two lines of code right here are pretty simple, I think, but they are crucially important. It's how we're gonna let any other widget talk to this map, essentially. It's terribly named clicked country, but I pretty much keep that naming convention for all of the interactive maps that I build. So I always know when I want to find the interactive piece, it's going to be called clicked country. It's really not a great name. But now we've got the ticker symbol, and that's really the key that makes this whole thing hang together. It's the key of taking that map and being able to pass your data to other widgets, other objects, pass it into a model. We're going to pass it to get symbols. So we're just going to pass in clicked country to get symbols. And we're going to call it ETF. And then we're going to pass it into DY graph. And we're going to pass it into HighCharter. All right, down here. The reason I did both is that I typically try to graph things in DY graph, but I think I might be switching over to HighCharter, so I figured I'd put them both in here and see what people like better, because that's really all that matters. And you can see that HighCharter has some nice built-in functionality, especially this. I like this this date functionality here if you want to change. I like that I can change it to year to date if I want to. DY graph I think makes it a little bit easier to add things to your graph. Should you so desire, so you can add this event for for the election, right? So I think it's a bit of a stylistic thing as which aesthetic you prefer, right? So just to sort of show you all how we did that, right? We have a reactive, click country, a reactive called ETF, and then we pass ETF and we grab the closing price. So that was why we did that test in the notebook to make sure that kind of calling CL on ETF was going to work out for us. So like I said, this is a pretty simple app. You know, no math, no models, no regression. So I'm really hoping just that I can convince y'all that you know, putting in some extra work to make things, you know, accessible and easy to use by our end consumers or our end users is worth the time. And it's really, sometimes when I talk to people about kind of mapping and hooking up other charts to them, and this doesn't have to be a map, by the way. This could just as easily have been a DY graph with, you know, 5 time series, and you can click on the time series you want and pop the results of a model that I'm going to run that time series through into another chart down here. You can kind of hook up these widgets how you want. So hopefully I've convinced you that it's kind of worth the time and the effort to do it. And the reason I kept harping on using a notebook in the beginning is that once you've put forth all that effort to kind of make all this stuff happen, it's great if you can reuse it, and if somebody can reproduce it, you can start from your notebook and kind of take advantage of the previous work that you've done. So hopefully I've convinced you, and if there's any questions, let me know, or I'll be standing outside at the RStudio table if there's questions. No one? All right, thank you.